Next question is exact savings. This question, chefs work in a restaurant where he gets X rupees per hour. And one day he visited a gift shop where the price of each gift is very high and there are at most 10 gifts. So, and initially chef has no money, so you want to work, you want to find the minimum number of work hours to work in the restaurant to save exactly X rupees after buying zero or possibly zero gifts from the shop. If he can buy gifts from the shop, you have to print the number of minimum hours that he has to work. Otherwise, if it is not possible, we have to print minus.
Yeah, let's see how we can solve this question. So let's take a sample case here. Here, the array values are 1, 2, 5. N value is 3. Basically, 3 elements are there in the array. These are all the prices of the gifts. And X value represents the wage, the amount of money he earns per hour by working in the shop, right? By working in the factory, by working in the restaurant, actually, yeah. And Z is the amount of money that he has to save, okay? So basically, he has to buy some subset of gifts and such that after he earns his money, after he earns the money, the subset of gift prices will be subtracted and the remaining value should be basically 12, right? So now the money he will have after working for some number of hours will be always a multiple of X, right? So let's say he works for K hours, okay? If he works for K hours, his earnings will be what? K into X, right? Now, K into X minus some subset of the numbers, right? Basically, he doesn't need to buy all the gifts. He just need to buy some subset of the gifts, right? So let's call that subset sum as S, okay? S is the sum of the some subset of values in the array, okay? So Kx minus S should be equals to Z value, okay? So basically, this is the one condition. So based on this, can we say that Kx equals to Z plus S, okay? Right? Now here in this test case, Z value is given to us as 12, X value is given to us as 5. So just by trial and error, we can figure out that if K is equals to 3, we'll get, okay, basically if K equals to 3, we'll get 3 into 5 equals to 12 plus S value as 3, basically, right? And we can get 3 by adding 1 and 2, okay? We can get this subset sum of 3 by adding 1 and 2. Basically, we'll achieve 15 here, and that 15 is possible by working for 3 hours, okay? So in this case, our answer will be 3, okay? Now, let's write this equation again, right? So it's Kx equals to Z plus S, okay? Now here, we know that this value Kx is always a multiple of X, right? So the sum of these two values should also be a multiple of X, right? Yes. So let's say in the question, it is given that the Z value they gave us, Z value is already a multiple of X. Let's say Z, okay, just a second. Basically, let's say the Z value modulus X equals to 0, right? If this condition satisfies, we can basically say that Z value is already a multiple of X, right? And in that case, we don't need to add any X, right? Since Z is already a multiple of X, we can, the value that we add to it should also be a multiple of X, right? But it's given to us in the question that we can possibly pick up 0 gifts as well. We can possibly buy 0 gifts as well. So I'll just choose not to buy any gift at all. And basically Z will become equals to Kx, right? And we can find the value of K by saying K equals to Z by X, okay? So whatever Z value they give, I'll do Z by X and I'll find out the value of K. Okay, but this is only in the case if z modulus x equals to 0, which is z is a multiple of x. Okay, so yeah, now let's see the condition if z is not a multiple of x. Okay, basically if z is not a multiple of x, which means z will return some remainder when it's uh, when we perform a modulo operation with x, right? So let's say r equals to some value which is z modulus x. Okay, and s will have to be a value such that when we add these two values, it should become equals to kx, right? So can we say that if this gives a remainder of r, this should give a remainder of basically x minus r, right? Because when we add these both values, we'll get a remainder of a number that is basically x, right? And basically x modulus x will again become 0, which is what we want to achieve, right? So from this observation, we can say that if r is the remainder of I'm sorry. Okay. Basically, if r is the remainder of z when you modulo it with x, then x minus r should be the remainder of s after doing a modulo with x. Okay. Now here, in the question, the constraints they have given us is that n value is up to 10 power 5. Okay. And basically, okay, let me just erase this part. Okay. Okay. So they have given n value can be is always less than equal to 10 power 5, right? And the x value they have given is less than equals to 10 power 3. Okay. And the a of I value is given as 10 power 9. Okay. Now the people who might have done dynamic programming might recall the standard question of subset sum, right? So with that question in with the logic of that question in mind, we can say that this looks like a subset sum question, right? But here the a of I value is very large. In the subset sum question, it's possible for us to find out the answer only if a of I value is like less, if it's like around 10 power 3, right? Only then we can do 10 power 3 into 10 power 3, like we build a matrix of size 10 power 6, right, in subset sum. So from based on that, we can say that it would not be possible to do subset sum with such a large a of I value, right? So what we do is, instead of finding subset sum with the a of I value, we'll find the subset sum with the a of I modulus x value. Okay. Now we know that x value can be up to 10 power 3, right? So a of I modulus x will also be less than or equal to 10 power 3, right? And with such 10 power 3 values, it's possible for us to find out the value, right? Now, if you observe in this question, we don't really have to worry about z plus s becoming equal to kx, right? We just need to worry about the fact that the remainder that comes from z when you modulo with x and the remainder that comes from s when you modulo with x should add up to x, right? We just need to worry about that single thing. Okay. So here, let's just write what the recurrence relation in dynamic programming will look like. Okay. So okay. So here the recurrence relation would be dp of I and j. Okay. Now I'll tell what I and j stands for. Here I stands for the array value. So in subset sum, what we do, we usually find the dp values up till the ith index, right? So we have the possible subset sums till the ith point, till the ith index, and so on, right? So I represents the index of array, okay, and j represents the value that we find after modular, right? So okay, this value can be from basically 0 to n minus 1. Okay, right? And this value can be from, or okay, let's take this from 1 to n. Let's call it one based index. Okay, because one based index will simplify some of the steps. Okay, so this is basically the index of the array, and j will indicate the modulo values, right? And okay, one more thing that they have mentioned in the question is that we need to minimize the number of hours he's working, right? So subset sum will basically hold the value of the minimum number of subset sum that we need to take in order to create a sum that satisfies these conditions. Okay. Now it might seem a little confusing, but it will become clear eventually. Now J will represent the modulo value. Okay. So that will go from 0 till x minus 1. Okay. Basically, the modulus of x can never be x. It can be in the range from 0 to x minus 1. Okay. Now, dp of ij will basically be equal to either minimum of dp of I minus 1 j. Okay. Basically, for every element, we go to the previous element and check, okay, what will be the minimum value to obtain a modulus of j, obtain a subset sum whose modulus with x gives us j, until the point I minus 1, until the number I minus 1th index. Okay. This is one thing, right? So basically, this includes the value such that a of I is not included in the actual answer. Okay. So if a of I is not included, basically we'll find the dp until I minus 1th index for a modulus of j. Okay. Either the answer can be this, or the answer can be, I'll write it here, dp of I minus 1 and in brackets j minus a of I. Okay. Basically, we do j minus a of I because in the previous part, if you go to j minus a of I part, what is the minimum subset sum there? We are finding that value, and we are adding this with a of I, basically. Okay. So this will be the recurrence relation. Also note one more thing, that since these are since what we are using is index modulus values, when we do j minus a of I, it might go below 0 as well, right? So to handle that, this should not be j minus a of I, it should be j minus a of I modulus x. Okay, which can be a negative value. So what we do plus x to that, and then we'll do a whole modulus x again. Okay. Basically, this will handle the case where if when we do j minus a of I, it becomes a negative number. Okay. So yeah, basically this is the recurrence relationship, and we can say that as a base case. Okay, let me just erase this part. We can say that the base case will be like dp of 0, 0 will be equals to 0. Okay. Basically, if we are including 0 elements, and if you want a modulus of 0 in the subset sum, then the minimum subset sum we achieve is 0 only. Okay. This will be the base case, and this will be the recurrence relationship. So with this recurrence relation, we can solve this question. Okay. And let's see what's the time complexity of this question. Okay. Okay. Basically, time complexity of this question will be O of n into x. Okay. Here n value is up till 10 power 5 and x value is up to 10 power 3. Okay. So this gives us 10 power 8 complexity. So it's very close to giving us TLE. So we might have to make minor optimizations in the code itself so that it doesn't give us a TLE. All right. So yeah, that is how we solve this question. And space complexity will be O of n into x only. Okay. Basically, we need O of n into x grid, size of the grid as O of n into x to perform all these operations. Okay. I mean, we could optimize this with only O of n. Basically, we can override the same O of n array multiple times. But yeah, it will also work with O of n into x. Okay. So yeah, that's how we solve this question.